Now that we know how to count sig figs, how to identify how many sig figs a number has, and what those sig figs are, we can apply mathematical rules to them. And we're going to see that this is, again, very important that we're able to convey to other people how precise our measurement was. So any number that's been measured that we're going to be using in a calculation, we have to apply Sig Fig rules. And we'll start with rules for multiplication and division. So with multiplication and division, remember those are essentially the same operation. When we're dealing with multiplication and division, the rule is we're going to take the lowest number of sig figs for any of the numbers we're dividing or multiplying. So if we take, for example, maybe we're doing an area problem, 23.6 cm times 1.8 cm. I don't know, this is a very narrow strip of something. Maybe it's a ruler we're actually measuring. If we do this, numerically speaking, we get 23.6 times 1.8, we get 42.48. The problem is, by the way, centimeters squared would be the unit. The problem is this number has more sig figs than either of the numbers we started with, and that's not correct. We need to end up rounding our number such that we take the lowest number of sig figs of any number we multiplied or divided by. In that case, we want to look at all the numbers we're multiplying or dividing. This number has 3 sig figs. This number has 2 sig figs. And as a result, our answer needs to have 2 sig figs. And when it comes to rounding, we always want to keep the largest values first. So that means in this number, we always, we'll keep the leftmost numbers. Those are the biggest, most important numbers. So we need to round this number, the 42.48, to 2 sig figs to indicate that our significance based on our measurement with this ruler, or whatever it is. And so we will round this to 42 square centimeters. And that would be the answer with correct sig figs. So with multiplication division, you take the lowest number of sig figs. And then for addition and subtraction, which again are the same operation, because one is a negative, right? The rule here is if we are taking multiple measurements and adding them or subtracting them, we have to see where the significance is. So we don't care how many sig figs this time, but we care where the significance is. And so we are going to always round off the least significant measurement. And so say I am, again, got some measurements here. I've measured my desk multiple times with this ruler. I don't know, 52.4 cm, 1.2 cm, and I don't know, 0.62 cm. Why not? When we add all these up, it's often helpful for sig fig purposes to do it the old school way, where we actually line them up, where you have all your decimals in a line and you see where everything adds up. So we end up with 54.22 when we added all this stuff up. But we need to round to our least significant measurement, which means the one with the fewest decimal points, or the one that just ends kind of on the left. So the last significant digit in the first number is that 4. The last significant digit here is the 2. And then for the last number, it's also a 2. We need to round to our least significant spot. So both the 52.4 and 1.2 have their least significant digit in the tens place, 1 decimal point. And so our answer will need to have our significance, and let's just change this number, by the way, just so we have something to do with rounding. we need to convey that our measurement, again, had that least amount of significance for the 52.4 and the 1.2. And so when we round this number, we round everything on the left, we're going to keep everything on the right, we're going to round away. And remember your rounding rules. If the number you're rounding away is 5 or higher, you're going to round up. If it is 4 or lower, you round down. And so this number, when rounded, becomes 54.3. So we're going to round that 8 up. We're going to increase the next digit by 1 to indicate that we've rounded up, and the 8 just goes away. And so our answer has significance in the 10th place, and that is where our least significant measurements happen to be. And so that's how we can subtract. It becomes a little tricky when we're doing both addition and subtraction and multiplication division, but it's really not that bad. When it comes to it, you're just going to follow the rules as before, but you don't do your final rounding until the very, very end. So do all of the same rules, kind of apply them, but don't round yet. So if we're going to take this number, the 54.3, and the 42 centimeters from before and do something with them. So let's say we have, we'll put them all together. So 23.6 plus times 1.8 centimeters. And then we're going to, let's say we're going to multiply it by 52.4 cm plus 1.2 cm plus 0.68 cm. So we need to do our parentheses parts first, right? That's the order of operations. So parentheses come first. We know that this number is, actually I forgot, what is that number? 42.48. So we have that 42.48. We know that this number will be rounded to 2 sig figs. If we were done with our calculation, we would round this number to 2 sig figs. But we're only going to ever round at the very, very end. So for right now, we're going to just remember that this number should have 2 sig figs, but we're not going to round it yet. Don't round it away yet. We also know, we've already done the math for the other one, that this number was 54.28, but that we should round it. If we were done, we would round it at that 2. And so now, when we actually multiply these two numbers together, they're unrounded. They're still their regular forms. We're going to multiply 42.48 times 54.28. We don't round the numbers before we do more math with them. And so now we do this. This is a cm, by the way. We get 2305.8144 cm cubed this time. Cm squared times cm cubed. We have to look what operation we just did. We just did a multiplication, which means we need to now follow multiplication rules. This number should have 2 sig figs. This number should have 3 sig figs if we had rounded them, but we're not going to. And since our last operation was multiplication, we want to pick the smallest number. So we will want to round this number to 2 sig figs. And so we're going to round it to 2300. Don't forget those zeros. Those zeros are very important placeholders. Remember, they tell us the magnitude of the number. So we're going to end up with 2300 centimeters cubed, and that will be our answer with appropriate sig figs. So, in recap, multiplication division, you take the smallest number of sig figs. If you're doing addition and subtraction, you follow where the least significant digit is. That means the number of decimal places. And finally, if you have both of them combined, do your operations separately. Pretend that you're doing the sig fig, so indicate where you would round the number so that you have that in your head, and then keep going until you're done with the entire calculation. Once you're finally done, you base your sig figs off the last operation you did. So our last operation here was multiplication, so we rounded based on multiplication rules. If we had added these numbers together, we would round to the tenths place. Let's just see what that would look like. If we were adding them instead, 42.48, 54.28, I can do this, nope, 6, or divide, okay, 96.76. Again, we need to now keep where our significance is. That 42 had significance to the 2. Remember that that 48 would have been rounded away had we been done. And our second number has the 2 as the last significant digit, as we see here. And so we will need to round away. So this number becomes 97. I don't know what the unit would be because we can't really add cm squared and cm, but just for an example. So we would always want to round it based on where the sig figs would be. But we don't round it earlier because that would introduce error into our experiment or our calculation. So we want to avoid that. All right, so that's how we do math with sig figs. Plenty of examples in the book you can practice on, and you'll have some time in lab as well.